In the last lecture, we started setting up our state machine for the player so that we could implement our wall slide state. Now, for the wall slide, we're going to have there's a few different things that we need to keep in mind. And so the way that I've set up the wall slide state for this game, I'll actually just show you real quick because I can bring it up and show you how it works on my reference project. So what we want to have is you attach to the wall and you begin sliding down like that. Okay. However, if you hold the down key while you're attached to the wall, you'll actually start sliding faster. So that's a mechanic that I wanted to add. And if you press the jump key when you're attached to the wall, you'll jump off of the wall. However, if you press a key away from the wall, you'll just kind of fall off of it. So you'll just kind of drop down. See that? We won't jump. And then lastly, the character should always face away from the wall, no matter which way the gun is pointing. And when you hit the ground, or if there's no longer a wall, you will leave the wall slide state. So there's actually some complicated logic behind this that we're going to be implementing. So let's start by getting what I call the wall axis. It's a little bit of we're going to make some functions for all these. So let's come down here. It's honestly a little bit of a weird way to word it. Get wall axis. So what is this going to do? It's going to check to the right of us and to the left of us for a wall. And then it's going to create a number that is either -1, 0, or +1 based on those two values. In a similar way that we get the X input for our up here at the top in our movement state, how we get the input vector right here. And this is based on whether they're pressing left or right or neither or both. We're going to do something similar to that, but it's going to be checking for walls. And it will go like this. Var is right wall equals, and we're going to use a new function that you guys haven't learned about yet, but this is a function inside of the kinematic body. It's called test move. And I don't actually know how good it is to use this function, like if it's a little bit processor intensive or what. But it seems to work fine for this game. Basically, we can test a move. So we give it our current location, or our transform in this case. Transform, which is like not just your location, but also your rotation and scale and stuff like that. And then we give it where we want it to go to relative to where we are. So that would be vector2 dot right, because we're checking for a wall to the right. And that's it. This will return true if there is a collision there, and false if there's not a collision there. Var is left wall equals test move transform vector2 dot left. So we'll check to the left as well. Then we return int is left wall minus int is right wall. This is very similar to what we do with the left key pressed and right key pressed thing. We're getting that information. If there's a wall to the right of us but not to the left, wall axis will be 1. If there's a wall to the left of us but not to the right, wall axis will be -1. If there's a wall on both sides of us, it will be 0. And if there's a wall on neither side of us, it will also be 0. Okay, once we get the axis like that, we can then check for jumping. So we'll say wall, slide, jump, check. which is the behavior I showed you where they press the jump button. We need to pass in our wall axis for this because we need to know if there's a wall on our right or on our left when we're jumping, so we know which direction to jump in. So we'll say if input.isAction just pressed UI up, motion.x equals wall axis times max speed. So that way, this is actually, we've set this up to the opposite. Actually, I just realized. And I guess that's fine. It's actually a little more convenient to have it be opposite. So if there's a wall to the left of us, or if there's a wall to the right of us, then this will be -1. And if there's a wall to the left of us, it will be +1. I didn't realize that I actually set it up that way, but it actually makes the rest of the code a little bit easier. So I'm just going to leave it, but just be aware that that's actually how it is. Motion.y equals negative jump force divided by 1.25. So I guess for some reason I decided to make the jump force slightly smaller when you're jumping off a wall, so you don't go quite as high. These were just value, that was just a value that felt good to me. State equals move. So obviously, if we jump off the wall, we want to switch back to the move state. There you go, that's our wall slide jump check. So that handles the behavior where we press the jump key when we're attached to the wall. Now, let's do a wall slide drop check. Wall slide drop check. And this needs our delta value. And this will handle the behavior when we press the right or left key when we're attached to the wall and we just want to kind of like detach from the wall, like drop off. So we'll say if input.isAction just pressed UI right, motion.x equals acceleration times delta. State equals move. If input.isAction just pressed left, motion.x equals acceleration times delta. It's negative acceleration. State equals move. So why are we multiplying by delta here? Because we don't actually have to. Technically, it's just so that we can use our acceleration variable here. And so then we detach at the same speed that we actually would normally move in a direction. And so that's why I'm using acceleration here. But it's a huge value if we don't multiply it by delta. So I'm multiplying it by delta. You could make a new variable called wall drop speed or something. I don't know. But this seemed like it was fine to do it this way. That's going to be it for that. Now we need a wall slide fast slide check. I didn't really like this name, but it's fine. We'll just name it this. It needs delta as well and a max slide speed. If input.isAction just pressed down, so we'll do UI down. So if they're pressing the down key, this is what lets them slide down faster. Max slide speed equals jump force. And motion.y equals min motion.y plus gravity times delta. So we're adding gravity to it, but we're going to cap it at max slide speed. so that we can never, which is basically just our jump force in this case, but maybe not, because we're going to set our max slide speed to something else. And since this is the only place we're actually using this, I'm seeing a little bit of a better way to handle this, I think. Yeah, we don't have to pass in the max slide speed. We can just pass in delta, and then we can say var max slide speed equals, just set this to 48 for now. So that's kind of like our default, but then it gets increased to our jump force amount, which is 128. But let's create this as a variable. Export int var max slide speed. Set it to, well, this isn't our max slide speed. This is just our slide speed. We'll set it to 48. We'll call it wall slide speed. Copy that and come down. Well, whatever. I was already almost there anyways. And we'll paste this here. That way we can alter it in the player's properties. So there's our slide speed, but our max slide speed is actually just set to our jump force. And maybe you don't want to tie that to jump force. And you could actually make, this is probably the better way to do it. Var max wall slide speed. And I'm going to make it the same as the jump force, but at least now we have a separate variable for it that our player can now edit. And we'll use that instead. So if they're pressing down, our max slide speed is going to be used instead of just the normal slide speed. Okay, we're getting close. I knew this lecture was going to be a little bit longer and a little bit more complicated. So let's move on to the next function. We need a detach check, and this is the last function that we're going to be using. Wall detach check. We'll pass in the wall axis. And we'll just say if wall axis is equal to 0. So we'll technically detach from walls if there's walls exactly on either side of us. But I don't want that scenario anyways. I don't want there to be two walls that are that close together. So as a level designer for this game, I would never design that level. But be aware that that is how this logic will work. Or is on floor, right? We want to detach if there's no walls next to us, or if we're on the floor. State equals move. Okay, we wrote all of the functions for our wall slide state. Now we're actually going to implement them all. And so let's start. So first we'll say sprite. Oh yeah, we need to set up our sprite for this. So come into your sprite animator. We're going to create a new animation called wall slide. And we'll just make it 0.1. And we'll come into our sprite, animation, switch to frame 10, key that frame. And that's it. We've got our wall slides animation now. So that's the first thing we'll do. Sprite animator dot set dot play wall slide. Now we need to get our wall axis. Var wall axis equals get wall axis, right? If wall axis does not equal 0, sprite.scale.x equals wall axis. So this will properly scale our sprite based on the wall that we're attached to, right? And there we go. We've got the proper X scale for a wall on the left. Let's try one on the right. And there we go. Proper X scale for the wall on the right. We're still not sliding, but that's because we haven't implemented our other functions here. Wall, slide, jump, check. Wall axis. So this will be the logic for checking for a jump. Wall, slide, drop, check. Delta. So this will be for checking for if we press left or right. Remember that logic? Wall, slide, fast, slide, check. Pass in delta here. This will be if we're pressing down, we'll increase how fast we slide. Now, funnily enough, we actually need to call our move function because this whole time, you'll notice, we've been modifying motion.x and motion.y. So in order for those to actually be applied, we have to call our move function again, just like up here in our move state. And finally, we do wall, detach, check, and pass in wall axis. So we can check if we need to detach from the wall. And all of our logic should now work properly. And we can now wall slide. Well, that's not working. Falling faster currently isn't working. So there's a problem with that one. We'll need to fix it. We'll be doing that. This is already a long lecture, so we'll do that in the next lecture. Thank you all so much for watching, and I will see you in the next lecture.